19th question, let's see. We have an air bubble. All right, so let me make that bubble here. So this is the air bubble and its radius has been given. Let's represent it by capital R. And this air bubble is inside water. That's fine. This is the situation, and the density of water that also has been given. And there's an interesting thing what's happening. All of us know that the air bubble would rise above and the value of acceleration is there. That's 9.8 centimeter per second square. So that acceleration has been given. The viscosity has to be neglected. We need to calculate the mass of the bubble. So the forces involved, one is the weight of the bubble, other is the upthrust. So on the basis of that, what we can say, the upthrust minus of mg will be equals to mass multiplied by acceleration. And in order to calculate the upthrust, you would see that's 4 by 3 pi r cube. That's a volume displaced, density of water, g, and that will be equals to ma plus g. You need to put all those values. Just be careful. Things are given in CGS unit, and that will give you option number 4, 4.15 gram as the mass of the bubble. The next one, question number 20, and let's see, photoelectric effect. And in this given case, you could see here, there is a graph which indicates the variation of stopping potential with the incident frequency. Look at the unit of the frequency, that's in the unit of 10 raised to the power 14 Hertz. We need to calculate the minimum energy for ejection of electron. So essentially, it's asking about the work function. How would the expression be related? That's EVS is equal to h nu minus of work function, right? And just try to see how do we understand the work function. In case of work function, if you want to calculate, you can just see at this particular point, point B, the value of stopping potential is 0. So if I concentrate on point B, I'm going very mathematically. Otherwise, if you go through physics, the minimum energy required, you can easily relate with 0 stopping potential. But if we go mathematically, at this point B, the stopping potential is 0 equals to h multiplied by frequency at B. And what is frequency at B? That's 5.5 into 10 raised to the power 14 Hertz. And that, once you put, will give you the value of work function. A little bit of calculation, option number 2 would be the correct one. Now we'll proceed for question number 21 through 25, which are integer based. The 21st question, that's been brought from the compound microscope optical instrument, and it's very straightforward formula based question. In that given situation, the final image is formed at LDDV. It's been given there. The focal length of the objective lens 1 centimeter. So let's say the focal length of objective, that is 1 centimeter. Let me pick out all those required things. The angular magnification in terms of magnitude that has been given, that's 100. The tube length that has been given as 20 centimeter. And based on this, we got to calculate the focal length of the eyepiece. Okay, now that goes on a very straightforward manner. The angular magnification, if I talk about the magnitude, is L by FO 1 plus D by FE. It's a straightforward one. You put all those values and you would get the focal length of the eyepiece as 6.25 centimeter. So what would be the correct option? That's going to be 6.25. Let's go for 22nd.